Namaste, ma'am. Ma'am, unmute, ma'am.
Good evening, students.
Ma'am,
Yeah.
your voice is a little low, ma'am.
I really do not understand why there is an issue with this class only.
Now it's okay, ma'am.
Okay, good. So, seems most of you have settled, or are you waiting for your friends?
No, ma'am.
Okay. So, do you recall the last class where we discussed about what are the subatomic particles, right? Now, can somebody tell me what is the meaning of subatomic particles? Quickly respond to my question, student. Yeah.
Can you repeat the question, ma'am?
I'm asking what is the meaning of the word subatomic particles? In the last class, we discussed that there are 3 subatomic particles in an atom named as electron, proton, and neutron. Then, can you define what is a subatomic particle? Or in other words, what is the meaning of word subatomic? See, in most of the cases, if you look at your lunchbox carefully, most of you must be having certain compartments made in your lunchbox. Similarly, inside atom, proton, electrons, and neutrons are placed in it. They are kept, or they can be imagined to be present at various positions inside an atom. And since they are present inside atom, they are known as subatomic particles, right? So this is one of the very basic question. What are subatomic particles? That they are electron, protons, and neutrons. And just for your knowledge, these are not only three. There are many more particles. Some of them I can mention, they are named as mesons. Not important for you to know, but if you get a multiple choice question, how many subparticles are present inside an atom? There are many more than three, right? The answer will always be more than three, not three, in multiple choice question, right? Okay. Now, after that, once we discovered three major or the three main atomic particles or subatomic particles named as proton, electron, and neutron, then we have to place them inside an atom. Where are they formed or where are they placed, right? And that was important so as to maintain the electrical neutrality and balance between the electron and proton, basically, right? Neutrons are neutral. They can be placed anywhere. It looks like so, right? They can be placed anywhere. Now, why can't we have structure of atom? Why we are using the word atomic models? The reason being, we are not able to see the atom. What best we can do? We can just think about that they are placed like this, this, and this, right? So therefore, they are still atomic models. There is no concrete structure to the atom. They are still in the model state. So first two atomic models, which we will be discussing, is J.J. Thomson's model, followed by the Rutherford model. Now, can you tell me, have you been taught about these models in class 9? And do you know the details of these two? Yes, please pick up the mic, anyone, and tell me the answer.
Yes, ma'am.
Okay. So now, can you tell me what is J.J. Thomson's model? Anyone again, can one of you speak about it? What is J.J. Thomson's model?
Ma'am,
Yeah.
protons are positively distributed, ma'am, in around the nucleus.
Protons are, I didn't get the next word, protons are. Can you please repeat?
Ma'am,
Yeah.
protons are distributed all over around the nucleus, ma'am.
Okay. Anybody wants to add to it or make any corrections into it? The attempt is partly correct. What's your name, dear student? Okay, I just want to make a certain correction into it or want to see. Please remember that you are in the era, you are in the time when you know about the existence of nucleus. Nucleus was not discovered at the time of J.J. Thomson. Nucleus, if you remember your Rutherford model, it is called as Rutherford's nuclear model also. So when we are describing Thomson model, we must not use the word such as nucleus, right? So now, can anybody improve that definition or the description of Thomson's model?
The electrons are equally distributed over the atom, and the remaining space is the positive sphere.
Correct. Correct. What's your name?
Ivana.
Okay, good. See, it was J.J. Thomson, and he received the Nobel Prize for it. And these are the specific points. I understand you have been knowing it since class 9th, but when we build up our concepts, when we move from Thomson to Rutherford to Bohr's atomic model, maybe to just touch up the Schrodinger wave equation and the latest atomic model, we need to have a comparative vision about it. Of course, direct question will not be asked on the topic of the Thomson's model, but we can always have a comparative question that how does Bohr's atomic model differ from either Rutherford's model or Thomson's model, right? So,
Ma'am,
you can, yeah,
ma'am, can you show the previous slide, ma'am?
yeah.
Atomic model slide, ma'am.
I didn't get you.
Atomic model slide, ma'am.
This
Yes,
one?
ma'am. Yes,
Okay.
ma'am.
If you are noting down, just quickly note down and let me know that you are done.
Completed, ma'am.
Good. So this is what I was saying that D.J. Thomson was awarded Nobel Prize for investigating the conduction of electricity of gases. He did not get award for giving us the first approved model of structure of atom. Now, these are the various names. As I was explaining at that time, that we must know, or rather from time to time, I keep on reminding that you must know as many names of a substance or a commodity or element or a compound as you can. So Thomson's model is named as plum pudding model, raisin pudding model, or watermelon model. As you have correctly described it without using the word nucleus. First of all, he assumed atom to be spherical. This point, I agree, is not emphasized in class 9 because it was not that relevant at that particular time. Now, please note it down. To him, the atom was spherical, right? He understood the radius of atom is approximately 10 to the power minus 10 meter or 1 Armstrong. He knew about it, right? And then, as you rightly said, that positive charge is uniformly distributed throughout the sphere. So electrons are arranged in such a way that they are at an equal or such a distance that proton and electron do not collide with each other. They are at a proper distance so as to have a specific distance maintained, specific energies maintained, and the atom as a whole becomes stable, right? Whenever you are not a good friend of somebody, what do? You prefer to sit at a distance from that particular friend of or the acquaintance of yours. Similarly, electrons and protons, according to Thomson's model, they have to maintain a certain distance so as to provide the stability to the atom, right? So sphere, remember, there can be multiple choice question or a reason assertion question that it is a positively, what is the basic bed or the basic container contains? The container contains the negatively charged cloud in which the protons are filled into it like the seeds of raisin or plum, right? Or the seeds of a watermelon also. So this is something it looks like, right? Is it clear?
Ma'am,
Yeah.
can you repeat again, ma'am?
See, I say that there are different names given to this particular model, that is watermelon model or a plum pudding model, right? This can be assumed as a pudding or a watermelon, which is made up of a positive charge. I believe you must have seen the watermelon, the internal red color structure of the watermelon, which has black color or a brownish black colored seeds into it, right? So that red pulp of watermelon is made up of a positive charge and electrons are embedded into it, right? we can imagine it to be like this, that this is the watermelon, which is having the all red colored part inside it, right? And these are the seeds. These seeds are nothing, but they are electrons. And the entire red content is a positively charged species, is positively charged sphere, right?
Yes, ma'am.
And again, the electrons, we cannot draw the plum pudding model stating that electrons are in a clustered manner. You should not draw it in a clustered manner, right?
Yes,
Now,
ma'am.
then there is every model has to be followed by its drawbacks. That why are you discarding it? Why are you not continuing it with? So the experiments which were conducted at that particular time, they could not be explained by it, right? Assuming it is this, that there is a sphere of a positive charge and electrons are embedded into it. If you assume it to be true, it must be tested against certain experiments. So the details of experiments are not available, right? And more importantly, we do not need them a lot at all. So, but it is important for us to understand that most of the, what I can give you a hint or just a satisfaction, that most of the experiment were based on conduction of electricity. After Faraday discovered electricity, they started experimenting with it. So most of the experiments which were related to, although the physics part of the physical science could not be, could not support this structure of as given by Thomson. So after that, X-rays were discovered. You may find this topic may not be relating to the structure of atom, but believe me, it is important and a part of that, because in Rutherford model, you just talk about one thing. You talk about alpha rays, right? Then we have beta rays also and gamma rays. And it makes us curious to understand what are these rays, right? And sooner or later, directly or indirectly, we have to know about the beta and the gamma emissions also. So it is important that before doing the Rutherford model, we understand what are the X-rays, just a basic definition. We need not go into the details. If at all we have to go into details, we will be talking in spectrum, electromagnetic spectrum, where you might have been taught in your school about the various wavelengths and the frequencies and the energies, right? So just X-rays are a type of radiations which were discovered by Röntgen, and he discovered X-rays when the cathode rays strike the target anode, right? As a deflection, the smaller waves were discovered. So he did not knew about the properties of X-rays, right? He was not able to understand, but X-rays, you must, as I have just put up an X-ray of a hand, or rather two hands here, to make you understand it is the same thing, which unfortunately when we meet an accident or somebody dear to us has an accident and they broke their hands or fractured legs or bones, right? So we will be understanding what are X-rays and what are their properties first before we move to alpha, beta and gamma decay, right? So as you can understand, I believe everyone in the class must have seen X-rays someday or the other. Do you know what is an X-ray? Please pick the mic and speak. Is there any discussion going on in the class? Can I help the group?
No, ma'am.
Okay. So let's focus again on the X-rays. They have a high penetrating power. That is the reason when the X-ray of hand or a leg or any broken bone is taken up, they penetrate inside the skin. You must have seen the word of caution in front of the X-ray room that you must stay away. Only the technician and the patient is allowed to be there, right? Because their penetrating power is very high. At the same time, you must have seen that X-ray person. If not seen, don't bother about it. Just remember the X-ray person is always dressed properly, dressed in such a way that the X-rays do not affect him or her, right? So they have a high penetrating power. Therefore, they are used to study the interior structure or what is inside that bone, whether it is cracked or not, right? They are highly energetic radiations. They may harm us in a wrong way also, right? The credit of discovering the radioactivity, not X-rays, the credit of discovering the radioactivity goes to Henry Becquerel. There is just a small story about it that he was once working with the compound of the elements named as thorium. What he did was, this discovery was accidental. It was not a planned discovery. He left some thorium salt in his drawer. After he returned, he saw certain expressions on the photographic plate which he left over there. That is how he discovered radioactivity, right? The radioactive substances include uranium, thorium, radium, and francium. Please note the names of, write down the name of the substances which are radioactive in nature. Please note down quickly. Have you noted it down?
Yes, ma'am.
Okay. See, the radiations which are emitted by the radioactive substances are of three types. One is called as alpha rays. Sorry, this one is symbol of gamma. We have alpha rays, we have beta rays, and we have gamma rays. In this sense, ray and particle have the same meaning because particles are the constituents of rays, right? So what we mean to say, the substances which are naturally radioactive and if they are made artificially radioactive, they will be emitting three types of rays. One is called as alpha rays, the other one is beta, and the third one is gamma rays, right? Now, what is an alpha ray? You have done the Rutherford experiment, so you must be clear about it. What is alpha ray or what is an alpha particle? They are doubly ionized nuclei of helium. That means they are He2 positive. They do not have electron. Atomic number of helium is 2. When it gives out 2 electrons, what does it become? It becomes He2 plus. Is it clear to all of you? Helium minus 2 electron will become He2 plus, or this is an alpha particle, right? they can ionize the gases. That means if they pass through or if they are allowed to pass through a gas, what will happen? Since they require 2 electrons back, what they will do? They will try to take it from that particular gas, right? As a result, gas will be converted into ion. Is this point clear to you?
Yes, ma'am.
Okay. They have less penetrating power as compared to beta and gamma particles, right? The reason being they are heavy. They are atoms of or the nuclei of helium, right? Now, since they are positively charged, anything which is a charged species is bound to make a deflection in the electric as well as magnetic field, right? Since they are positively charged, they move towards negative charge in a electric field. So what are alpha rays or alpha particle in a nutshell? Most important point for us to remember is they are the nucleus of helium. They have a penetrating power but less than beta and gamma particles, and they show deflection in electric as well as magnetic field. Talking about beta particles are negatively charged. In fact, they are made up of electrons, right? Since they are made up of electrons, they are lighter than alpha particles. So what will happen? They will have a higher velocity. They are lighter, so they can move with the faster velocity. Their penetrating power. I believe you understand this meaning of this term. Penetrating means they can go inside it. If this is my hand, they can penetrate it better. They can move from one end and come out from the other end more easily as compared to the alpha rays or alpha particles, right? Now talking about, so what are beta? Alpha particles are positively charged. They are nucleus of helium. Beta particles are negatively charged. Now talking about the gamma rays are not charged. They do not have, they simply have energy. They are energy particles, right? They have more penetrating power as compared to alpha and beta because they are massless. They do not have mass. They just have energy, right? They are neutral because, as I told you, they do not have a charge. They do not have mass. This is just a comparative study of alpha, beta, and gamma rays. You may be feeling disinterested into this topic, I agree. But if somebody says, instead of alpha, this is a question, you may find it in the test, that instead of alpha particles, if I use if Rutherford, just become a Rutherford, right? Become a Rutherford and tell me that if beta particles or gamma particles are used, have we got the same structure of atom?
Yes, ma'am.
Yes. How? For what you have said, yes, ma'am, I really do not understand.
Ma'am.
My question, yeah, whatever you are saying, if you are saying yes, ma'am, then you back up with your with what reason? Yeah.
Repeat the question.
Okay. The question is, since I felt that you might be feeling a bit bored and you might not be interested into it. It might have been have been discussed with you in such a detail. I'm saying, do you know what is Rutherford's experiment?
Yes, ma'am.
Okay, please tell me.
He passed the alpha particles in a gold foil sheet, ma'am. Some of them were deflected, some of them were passed in a straight line, and some were passed in right hand at 190 degree.
Okay, agree. Now, my question, what's your name? Just tell me.
Retrieval, ma'am.
I didn't get you. Please.
Retrieval, ma'am.
Okay. So, I'm saying that instead of alpha particles. Yeah.
Sorry, ma'am. Actually, I didn't. Isn't that question? So I said
Okay.
yes.
No issues. See,
Don't take it as night.
no, nothing. Alpha particles, if instead of alpha particle, if Rutherford took beta particles or gamma particles, what would have been the results? You got my point? Or the question is on the display now. If rather instead of taking the alpha particles, very correctly you said that or all the students agree that in Rutherford experiment we study that Rutherford bombarded the alpha particles on the thin gold leaf or a thin gold foil. Now, instead of alpha particles, had he taken beta particles or the gamma particles, would he be able to give us the same result? Would he be able to describe what is an atom like? Now, my question has a reference to it because this is one of the questions I could see in NEP scenario where you are made to think about it. I completely agree. Alpha, beta, and gamma are not in beta and gamma are definitely not in your syllabus. But if you have to answer this question, dear students, you must know this, right? So think logically and answer me. That if he has taken beta particles, because see, the standard of question and the standard of knowledge from class 9th has to be elevated to class 11th students. You have grown up in size and age both ways, right? You have gained certain intelligentsia also. So we must improve your understanding of atom, right? So we know the classical experiment, we know. What did Rutherford did? The reason of spending or discussing this is we need to know the finer details or nuances of what he did. So have you understood the question? That is one thing. Have you understood the question? Then we will come to the answer. Have you understood the question? Anybody want to make an attempt? Let that be incorrect. We are always not right. Just to have a answer is always a good. Just please speak. Do you want to answer it or should I answer?
You answer. Ma'am.
Okay. Yeah.
Ma'am, they were negatively charged and they didn't have high penetrating power as compared to alpha particles.
Okay. You said one part correct, that beta particles are negatively charged and their penetrating power is more. You can see on the screen. The first point, the penetrating power of beta particle is 100 times more than that of alpha particles, right? So, what do you want to say again now? It's good that you are discussing.
Ma'am,
yeah.
Then it will pass like alpha particles, ma'am. More than in a straight line.
I'm not able to understand what you said. Can you please repeat it?
Ma'am, then beta and gamma rays also pass, ma'am, like alpha particles.
Okay, I'll come back to it. I want to discuss Rutherford experiment or make you recall Rutherford experiment with certain more facts about it. First question. Do you know what is zinc? The Rutherford experiment has a zinc sulfide screen.
Yes, ma'am.
Okay, what was the reason for having a zinc sulfide screen then?
Ma'am, if if a ray passed in a zinc sulfide, it will be uh, it will be brighter, ma'am, while passing that zinc sulfide solution.
Okay, got it. Partly correct or correct answer. See, these are the certain details which we miss at times and which are important for class 11th student. Rutherford conducted his experiment with his students, that Grigor and Madsen, and they bombarded the thin gold foil. This is important for you to remember, that thin gold foil. Again, had it been thick, what would have been the answer, right? It was about 100 nanometer with alpha rays, right? Please note down the thickness of gold foil was 100 nanometers only, practically invisible sheet, right? Then what we know what is a speed, the alpha particles are highly energetic. Now fluorescent, do you know the meaning of fluorescent? Again, the words which are highlighted in red can be a question of a concern or can be asked in the examination in any form. I can still see a lot of murmur in the class. Is there any doubt about it?
Ma'am, no, ma'am.
Okay. So what is the meaning of fluorescent? I'm listing down few questions which we will be discussing. Number 1, if he used thick gold foil, then result would be,
Ma'am,
yeah,
fluorescent means glowing substance.
fluorescent means flowing. I didn't
Glowing
get
substance.
glowing, right? Correct. And if he used, I say, a square or a rectangular screen, right? Now the correct word which I was, you are right, but I was looking for the correct word, that is scintillations. SCINTILLATION. Scintillation. That whenever, see, you have a small piece of a stone, and if you throw it in water, what happens? It creates a sound and it creates a ripple, right? Scintillation means it will make a small sound noise and a flash of light will be visible over there, right? So please remember this word, scintillations, or some people call it as scintillations also. So whatever we were doing before this class about the Rutherford model, I want to add few more things to it. That is, 100 nanometer was the thickness of the gold foil, and zinc sulfide screen is fluorescent and circular, right? The setup was something like this. Now, the one question was why this was circular. Now, this is source of alpha particle. Can you name what can be the possible source of this alpha particle? What material he could have used? Any answers?
Gold foil.
No, gold foil is there in the center. Gold foil is here. I am asking what could have he used as a source of alpha particles?
Doubly charged helium particles.
No. From where he will get the doubly charged helium particles? That's my question, students. See, let me go back what I have taught you and what is the importance of it. Go back to Henry Becquerel. In the slide, I have told you the names of the elements which are used, which are radioactive. They are found in nature. They are radioactive. Uranium, thorium, radium, and francium. Right? You must have studied, I believe, that periodic classification in your school by now. So you must be knowing where they are found in the periodic table. So he could have used uranium or thorium. I was looking for that answer, right? So have you noted the names of the naturally radioactive substances? Yes or no? Please be louder. Grab the mic and speak. I am not able to listen to you.
Yes, ma'am.
I'm not too sure what you said. If you have to want to look at it again, I'll get back to that slide.
Yes,
See, the source of this could have been uranium, or he could have used thorium, right? The source of alpha particles could have been this. Another thing which you must notice, that everything which is being emitted is allowed to pass through the lead plate first. What is the role of lead plate in this image? To make them in one direction. Now, alpha particle is an atom which is spherical in shape, right? The source, from the source, alpha, beta, and gamma particles can be thrown out in all the directions, and they may be harmful. Lead is there to absorb the extra beta and gamma particles. This lead plate has a small hole from which only the alpha particles are allowed to move, right? Now, when they pass through it, they strike on the walls of this material, that is zinc sulfide, right? When they strike on the zinc sulfide and they bounce back, and they can be seen here and there. Is it clear now? Is the role of lead plate clear to all of you?
yes, ma'am.
Okay. And the role of photographic plate is that as the alpha particle is passing through it, it must be deflected in any direction, and on the photographic plate, that is photographed. You people have lived in the era of the cameras inbuilt in your mobiles, but you just visit a photography shop. There you can see the photographic plate and the negatives of your photographs, right? Now, this is what all of you know, that when a beam of alpha particle is passed through them, some of them show a small deflection, some of them pass through straight, and very few of them return back, right? So from this, this is another version of the same thing, that when you bombard alpha particles, some will pass straight, some will show a small deflection, and some will show, they will go back to the original path. This all of you know, so I'm not going to spend any time on it, right? This number, if you wish, you should remember. Only a very few particles. Now, very few means 1 out of 20,000, right? Is it clear? This number may be important for you.
Yes, ma'am.
Okay. From this, they concluded what you already know. That the atom at the center has nucleus where the proton is found, and outside nucleus, the electrons are moving in a proper paths, or fixed paths are there, right? Now, since only very few particles moved back on their at 180 degree, that means the positive charge is concentrated at the center, and that is called as nucleus, right? So that's how we assume nucleus. Again, this data is important, that the radius of atom is 10 to the power minus 10, and radius of nucleus is 10 to the power minus 15 meter, right? Now this again, all of you know very well. What is a nucleus? What is an orbit? This we know very well. Now, before we talk about the drawbacks, let's come back to the questions. It was just a reminder for all of you. Whatever you know, there is nothing new I have to add on to it. But of course, these two questions, you need to answer. Now, can you answer these questions? Students, quickly think and answer the first question. Had you used thick gold foil, then the result would have been yeah. Any answer?
I don't know.
See, we understand. I'm answering the question now. I cannot hear any answer from any one of you, so I need to answer this question. Now,
Okay, ma'am.
okay.
100
If you have any answer, just let me know.
100 nanometer.
Okay. See, penetrating power of alpha particle is less, right? So what would have happened? They would not pass through the thick gold foil. I can still hear a lot of murmur. Please pay attention. Right? Had he used a thick gold foil, he would not have got these results, right? Because alpha particles would not have passed through, and they would not have shown you any deflections. Is it clear now? Please say yes or no.
Yes, ma'am.
Okay. Then if we use a square screen, see, this was the source from where the alpha particles were coming. The screen was circular so that all the alpha particles could be captured. Had he put a square screen, he could not have achieved that particular number of alpha particle deflections. We understand the circle will have a better coverage, right? If I have any object, right, the circular covering is always better. So the shape circle, the answer to the second question is, if he used a square screen, then the number of alpha particles hitting it would be less, right? Now coming to the question, if we use beta particle instead of alpha, what will happen? I have told you beta particles are negatively charged. Now we can backtrack it. Now we know that nucleus is positively charged. What will happen now? Now that is a clue for you. Now, do you want to attempt the answer? That alpha particles, let's assume alpha particles are not available. We have to use beta particles. What will be the results? Dear students, please respond.
Ma'am,
Yeah?
electron will not move fast, ma'am. Like how beta particles moves. It will not. It will not reach the nucleus.
Beta particles are electrons, student, and alpha particle are helium-2 plus. If you talk about in terms of mass, alpha particles are heavier. I'm giving you another clue. Think about the charge. Charge on the electron and charge on the nucleus. See, nucleus we know is positively charged, and the bombarding beta particles or the electrons, they are negatively charged, right? The moment they reach towards the nucleus, they will be attracted towards the nucleus. Do you agree with me or not?
Yes, ma'am.
So what happens there is that instead of being deflected, unless or until they show deflection in different directions, we cannot make any conclusions about them, right? So if we use beta particles instead of alpha particles, Rutherford's experiment would definitely fail, right? Because
Yes.
electrons will not be deflected. Electrons will be attracted towards the nucleus, and that will not give any conclusion to the scientist. Now, if I want to use gamma particles, can you predict the answer? Can you predict the, can you use gamma particles in place of alpha particles?
No, ma'am.
Why? Every time you will find me asking you why.
No, ma'am.
What were gamma particles? Just tell me.
Very energetic, ma'am.
They are made up, they are energy packets only, right? So energy packets can be absorbed by the nucleus or cannot be absorbed by the nucleus. Again, they are not going to show us the deflection as the alpha particles do. So again, the Rutherford's experiment, if I want to do it today, will fail, right? Or had Rutherford not conducted this experiment, he would have, had he used gamma particles, he would have failed, right? Now, let us quickly understand what are the drawbacks of Rutherford's atomic model. Can somebody tell me? I have written it in a technical language. Can you explain it to me in your language?
What? They don't have mouse.
In a layman's language, we say if a particle is moving, if around a charged particle moving around a charge, right? They will always be, there is always they will be attracted towards each other, right? If it is moving like this, just look at it. It is can you see it? Like if the electron is moving like this, it is always emitting energy. Now, when it is emitting energy, it will start moving at a shorter circumference, right? So ultimately, it will fall into nucleus. So it is this. That's just another depiction that if electron is moving, it will emit the energy and fall inside the nucleus, and atom will not exist. That was one of the reasons why we discarded the Rutherford's model, right? The calculation show us, see, that is again can be important, that if we say that Rutherford's model is 100% correct, that means atom is not stable at all. Within 10 to the power minus 6 seconds, it will fall down into nucleus, right? Then the second thing which it could not see, Rutherford's drawback, if I ask you to write two problems or the two reasons. The first one is it does not explain the stability of the nucleus. The second one, it does not tell anything about the distribution of electrons inside the nucleus, inside the atom, sorry, right? Now, do you understand these two terms, continuous and discontinuous? Students, please respond. Do we understand the meaning of discontinuous and continuous?
Yes, ma'am. Yes,
What is the meaning? Just tell me.
When electron loses energy. Yes, ma'am.
Okay, well, spectrum is anyway we are going to study in the next class. Okay, to end the class, just answer this question. I want to replace the gold foil. Gold is an expensive metal. Aluminium is a cheap metal. I want to replace the gold foil with aluminium foil. Can you predict the answer?
Because gold is gold is the price.
One by one, take a mic and speak. Do you have an answer? Are you ready with your answer?
It is 1000 atom thick, ma'am.
I didn't understand. Just say it again.
Yes, ma'am.
No, I didn't understand what you said.
It is 1000 atom thick, ma'am.
Still unable to understand, but I'll explain it to you. I believe I still do not understand actually. What you have to do, compare the masses of gold foil and aluminium.
Gold foil has more alpha particles.
No, gold does not produce alpha particle. Gold, see, I can just imagine it to be a thick sheet. It's strong in itself, right? If you hit it with something, what will happen? It will remain as it is. But if I take a thinner sheet, yeah.
Gold is most.
I cannot understand what you people are saying. Just listen to me. Let me explain it to you now. See, I'm saying if something is going to hit on this strong sheet, yeah.
Aluminum is less attractive than gold, ma'am.
Attractive means? I think you want to say something else and you are probably not able to get a correct word. It happens with everyone. It happens with me also. See, just pay some attention to get the answer. See, assume it to be a thick sheet, right? Now, if you hit something on it, it will probably, if you hit it with like a small stone, it will not change its position. It will remain as it is, right? But if I have a thin sheet, maybe a piece of a paper, or this is thin as compared to what I have earlier in my hand, what will happen? The moment I throw a stone on it, it will jitter, it will shake like this, right? Now, same thing happens with the gold foil and aluminium. Atomic mass of aluminium is 27 and that of gold is in hundreds, right? So that means the gold foil itself is pretty heavier, right? Its nucleus is heavy, right? So therefore, it will remain at its position and many alpha particles can hit it and move in different directions. But if you have aluminium atom, it has a smaller weight, right? And a smaller positive charge. So the deflection, if at all, will be very small. Is it clear now?
Yes, ma'am.
Students, you want to note it down or you have done it?
Ma'am, this is the time for disposal, ma'am.
Okay. So I believe you understood some other aspects of Rutherford experiment and J.J. Thomson's experiment and their models. So let's wind the class now. I'll see you in the next class. And please
Okay, ma'am.
revise and recall. I still have one question to discuss from the Rutherford's atomic model. Right? See you in the next class. Have a good day.
Thank you, ma'am.
Welcome.